we know that as you increase in this series motor, right? In the series motor, I have my supply V connected to series coil going to the armature. Okay, RSC, RA, and 5SC, and this I call IA. Already we know the ISC is same, but ISC equal to IA already we know that. Again, repeating no need. So we told that TA is proportional to IA square. That means this is my VS. VS, if I increase the VS for given RSC and RA, automatically ISC increases same, because ISC same IA, both are increasing. Okay. As you increase this one, what will happen? With actual equation, sorry, TM. Okay. TM already we said that 5SC into IA. 5SC is proportional, that's why this 5SC has increase the voltage from 0 to 100 volts. This ISC increases from 0 to some excess value. Excess value is not a maximum VS divided by the resistance values. Okay. So at one stage, because of the current flow, there's a magnetic flux happens. The magnetic flux density, we call this magnetic flux density, will, as the current increases, ISC increases, the 5SC will increase proportionally. It varies from 0 to, for example, 10 amps. This may vary to 0 to 10 Tesla, for example, or Weber's meter square. It increases, correct? So that means at a particular current, not full this one, maybe many times the motor coils are designed such that at say 7 amps or 6 amps current, correct? The 5SC becomes what you call a 5 max, which is called a saturation. Beyond that, if the current increases 8, 9, 10, if you increase also, the 5SC, the magnetic flux, if you measure in this coil, it will not vary. Okay, it will not vary. Okay, that means that is so. Because of that, if you draw the current versus the torque curve, correct? So in series motor, I say 0 to 10 amps. This is my IA. Okay, IA is same as ISC. Again, I'm repeating. So this is varying 0 to TM. Say for example, 10 Newton meter. Okay, you will see that initially the torque will increase non-linearly because you have IA square, correct? IA square, because of that, the torque increase as the current goes 1 amp, 2 amps, 3, sometimes it increases. It may increase something like this, non-linearly. But at particular current, as I told you, for example, this is, I said 2, 4, for example, this is 6 amps. At 6 amps, the IS, 5SC becomes saturated. Design is such the core material, all this in design. At this much current, the flux generated by field coil gets saturated. After that, so that means this is not increasing in your equation. We know that TM is proportional to 5SC into IA. Correct? So current is increasing, but the magnetic gets saturated. That means it doesn't have any effect. So after this point, then the torque curve will increase like this, which will become linear. So this is the normal current versus motor torque current, correct? But we saw that in case of shunt motor, it is always like this. It is always straight. But in case of this one, you need to see this is for green one is for shunt motor, TM shunt. The red one is TM series motor. So that means when the current is low, when the 0 as increases, the torque produced will be high. For this small amount of current change, more torque is producing because this is non-linear. Correct? This is one of the important carriers of series motor. Okay. So this property is used. Suppose you have a large load. Correct? Some, for example, crane. Correct? Crane has to lift or elevator. We call it, correct? But when passengers are inside the elevator cabin, correct? We say lift, correct? Or in the crane, it has to say for 1 ton. Generally, what they use is crane, lift, wherever you want very high initial torque to overcome the static frictions, correct? Or gravitational force against that. Then they use series motor. correct? So because it produces very high torque at initial stages, after the core saturates, after this, the torque production become linear. It is directly pro IA only, not IA square. Instead, this region, it is IA square. After the particular region, when the 5SC or series coil magnetic field gets saturated, after that, the torque production is proportional IA only, not IA square. That's why. So this is the one of the important. This characteristics helps series motor apply to wherever you need high torque at low speed or this one, like lift, crane, all these things. But when you want constant smooth torque, you have to go to what you call as a shunt motor. Shunt motor maintain constant torque, correct? Almost constant speed is self-regulating. All this thing, that is the advantage of shunt motor. Okay. So after this region, Tm is proportional to Ia. This region, this lower part, Tm is proportional to Ia square. So because of that, curve is like this. Note on this. Okay. So,
sir, I have a question over here.
yeah.
Can I ask?
Please.
Sir, why the current is
Why current?
hello?
Tell me.
Yes, sir. Why the current is like 5 is what is the limiting parameter which ensures that the current is saturated? Like what I mean to say
That
is
is core
after
core
saturation current,
material
the 5
designs.
is
No, core material designs. Correct.
okay.
Magnetic for created core matter. After that, the material part, whatever contents of nickel, chromium, and iron, the proportion, whether just pure iron, how much per all those things decides what you call magnetic reluctance. This like similar to resistance. Magnetic reluctance is called as R. I think last semester also we talked somewhere about when we talked about inductor, correct? Reluctance, magnetic reluctance. For example, you have core material over which there's a coil. The coil produce magnetic flux. For example, I have a core made of magnetic, with a solid core, a rectangular shape, over which, but it's not a magnetic material, it's not a magnet. And this is a magnetic material. I apply voltage, correct? So I say V supply, there's a I supply. So there's a magnetic flux created. That magnetic flux goes inside this material, comes out, correct? So so this material has what you call a magnetic reluctance, similar to electrical resistance, correct? Electrical resistance R equal rho L by A, correct? Rho is the resistivity, L is length of the wire, A is the current. Similar to magnetic reluctance. So that means the magnetic flux is entering. Magnetic flux is created by coil and it enters into, it is attracted by the core material, which is made of magnetic material. It has to magnetic material, not aluminum. Core should be made of iron or iron plus cobalt, nickel, that composition, not aluminum, copper, all this thing, correct? If the core is a magnetic material, it enters inside this one. From the coil, it generated, it enters since it comes here. So here, this has magnetic R. That's the equation, magnetic reluctance equation. Already last semester, when we talk about mechatronics, inductor, I talked about this. There's a formula. R, the area, cross-section area of the coil, core material properties, correct? All those things. Like resistivity, there's some property. So all these things from that reluctance. So this is how much magnetic flux can go. Beyond certain point, because the magnet cannot enter, correct? There's no, that depends upon the material property, size of the cross-section area of this one. So similar to that, here in the armature, all this thing made of magnetic field on which you have a coil. Please note that armature field both are electromagnets. It is just not coil hanging in the air. It is wound over a magnetic material, correct? We have the poles, and then you have armature, correct? These are magnetic material, made of magnetic material, on which we have the coils, correct? Copper coil through which current we are supplying, and it comes like this. And for the second coil, I will show you this one again. This is my VA. Here we supply VF. So you have IF and you have IA. So phi A, phi F. So the phi F value depends upon the magnetic property of this and also current. Both matters. Correct. But that means beyond supply current, if you supply also, magnetic material, magnetic field created get already saturated. This material cannot accommodate more than that. It cannot allow more than that. The magnetic reductance opposes. We say
Got it, sir. Got it,
then
sir.
we say the core is saturated. So core material
Got it,
selection
sir.
also very important.
And sir,
Yeah.
second part of the
Please.
question is that unlike shunt motor, sir,
Mm.
shunt motor में आपने बताया, you have told us that if we increase the current beyond a point, the torque is not going to increase because of friction losses and basically the copper loss in that sense, right?
Yes. Yes. But this is not
Now
self-regulating.
in
That
this
is, this is not self-regulating. You have to be very careful. Without load, you never. And most important thing, when you go to see any DC motor, find out whether it is a shunt motor, series motor. Series motor means that means you have the motor, correct, connected to load. Correct, it is connected to load. See, if it is a series motor, correct, without load, never switch on. Never switch on your motor. Because of these characteristics, the limit, his speed can go very high. The motor itself, because centrifugal, it come into pieces and hit the people around, including you. It is a really careful, correct? Series motor never should be switched on without load.
Noted, sir. So basically, beyond if you keep increasing the current,
speed will
the
increase,
torque will
go on
increase,
increase.
it
It can go very, very high.
It may blast.
And because centrifugal pump, it can come in pieces. The force is so much, the body of the motor, all the bolt nut, all shear forces, that forces will be so high, it can come out. It should be really small motor itself very this one. Series motor can go 10,000, 20,000 also without load, no load condition. That's why you should switch on the series motor only with load. Otherwise, there are chances.
Thank you, sir.
Again, but here also you have the back EMF. Here also is a back EMF. Yes, please.
Sir, only one doubt, sir. Sir, what is the advantage of series motor over shunt motor, sir?
Heavy torque at low speed.
Which applications are we are using series motor?
Lift, I told you, crane. Correct. For example, you go to suburban train, correct? Electric trains are there. Not I am talking about this one. Suburban train you can easily see. Inside city, what you call suburban train or electric. There you just get in. Then if you stay close to the engine compartment in the suburban train, initially because there the motor is initially operated as a series motor. You need more torque. So you have 6 or 7 carriages. There will be a motor. You will see that the driver first will put the motor in series mode, and you will see so much noise will come. Enormous torque will put a low speed. Then after traveling half a kilometer something, when your train reaches say 20-30 kilometer speed, then you will see suddenly a change in sound, motor sound. He will change the motor into shunt mode. So the driver on his dial, you will start with series motor mode. So more torque is needed because passenger to a rest condition. Once your suburban train reaches some speed, say 20-30 kilometer, the motor will be configured as a shunt motor. Then shunt motor also speed will increase. You can increase speed by increasing voltage, but generally try to maintain a constant speed. Correct. So for example, I am talking Chennai. I get into this Saidapet. Next station after 3 or 4 kilometers. Correct. So initially for half a kilometer thing, it will be series mode. You can see motor will be getting maximum torque. So wherever you need maximum torque, like this crane, correct. Crane has to lift heavy lift. Initially you need more torque. Those conditions you use series motor. Crane or lift motors also sometimes they use series motor. But if you want constant speed, continuous, this is smooth, this one, then use shunt motor. Okay. Again, the equation for speed, the motor speed, N equal to 60A into VB divided by P5Z. Z, A, all this thing already you know. Same thing only what we said. Correct? Number of parallel, number of core, and N is the speed of the motor, P is the pole, pi is the flux density. Once in the exam, if these values should be given, and then you need to find out. Otherwise, sometimes, yeah, you will be given whatever necessary. Suppose here is there VB equation also can. VB is proportional to omega, correct? Then already we saw the equation for VB in the previous class. If you are there, then you need to calculate VB, substitute VB here, then find out VM for a given number of poles, number of Z, A. These are constants will be given. 60 is constant already. So note down this. Okay. Now, if you wanted to see the important characteristics of the series motor, we are talking about DC series motor. So if I talk IA, that is armature current in A, IA is ISC, both are this one. Okay. Then N in RPM, 0 to say 10 amps. For example, I'm saying 10 amps and 0 to say 30 RPM. Correct? The speed curve of the series motor will be like this. You can see that the speed initially very high. That's why I told you have to be very careful. See, when current is low, at lower current, you see the speed is maximum. As the current increases, IA increases, the core gets saturated, then the speed will start dropping. As you increase the current in the series motor, the speed will drop. And low current, that means you apply voltage, speed will be maximum. So that's why I say initial speed wave without load, don't switch on. Again, next one, torque versus curve. Say T motor, 0 to 10 Newton meter. Okay. Now this is speed RPM. The curve also will be like parabolic. You can see the both are parabolic. But in shunt motor, if you have seen that, it is a parallel, correct? If I remember shunt motor, yeah. See here, IA versus speed is a constant speed motor. Even if you load, it will try to maintain speed, self-regulating. But in case of DC series motor, it is not self-regulating, like a shunt motor. So that is the very important characteristics. Okay.
Thank you, sir. Thank you.
Yeah. So where it will be used, Sylvia asked, you can note down series motor, series DC motor should not be run. Should not be run without load because of this characteristic. See here, very high. You can, I showed here, it can, some motor can go, the speed can be 10,000 RPM also. Initially, it will be very high RPM. That's the basic nature. If you do no load means within few seconds, motor will go to maximum speed and to do all things can happen. Cancel without load. Okay. Then application, heavy loads. Heavy load can be because the torque also, it produces very high torque initially because of that. Okay. So can be handled due to high starting torque, because of high speed, correct? Uncontrolled speed, high centrifugal force is generated. No load condition. Please note that no load. If load is there, motor cannot, because it cannot, you have to overcome. Okay. So as your current increases, see current in a series motor, shunt motor, the torque is proportional to current. If you want more torque, you have to give more current. As you give more current, you can see the speed drops. But initially only the problem. That's why without load you have to do. Generated forces may damage the motor. At no load condition. Applications, high starting torque application, any high starting torque. you don't use shunt motor, you use a series motor. Next one is high initial acceleration. As I told you, trains, electric suburban trains, you want to accelerate. Now you stopped in the station, you have to accelerate this one, more torque is needed, more acceleration. So in that case, initially the motor will be run in suburban train, you literally can hear the sound, change in sound. Initially it will be screaming sound, the torque will be more, you can sense the acceleration. Once it reaches, suddenly you will see it become constant speed mode. The motor will be running. That you can observe if you are very close to the engine compartment or electric motor compartment suburban. High acceleration needed, you can use, or a high acceleration and high torque. Only when high torque is there, acceleration will happen. Please know that acceleration is a byproduct of the torque. Torque only motor produces, correct? So if torque is not produced, acceleration will not happen. So high non-linear curve, no, torque curve is non-linear initial stage. Already I showed you that, correct? As the current increases, the curve is something like this, very steep. Within few amps, after that it becomes flat. Correct? This is IA versus T. Then third one, as I told you, high speed operation with light load. Anybody can say with light load, I said, why I am using light load? Just now somebody asked question also. Raushan or somebody asked, anybody? The curves also I showed, previously also I showed. Because you can see, as the current increases, the motor speed also reduces, correct? The torque production also reduces. Current also, because the VB acts. Please see that the currents go on reducing. When current is coming down, as speed increases, correct? The IA reduces. IA reduces, torque also will be less. Correct? As this motor, series motor speed increases, the torque produced by motor will start reducing. So you cannot drive high loads at high speed with series motor. So light load you can drive even at high speed. But if you want to drive high load and this one, you have to go for shunt motor because it can carry heavy load also. Okay, now that we saw two types of DC motor, correct? Where the DC motors are used, applications. I can say advantages are still they are using DC motor, mainly the speed control. We will see that in one maybe in few minutes or over a wide range is possible. 0 to 10,000 RPM, 0 to 5,000. See, motors a full range you can control, DC motor possible, correct? Sometimes over and below the rated RPM. Speed, okay. By how you will do? By speed is controlled by controlling the flux, controlling the field or armature flux / armature flux. Correct? Armature flux is controlled by this. Basically, what mean by controlling flux? Nothing by controlling voltage. See, controlling voltage controls current. If you control current, flux current. Flux is produced by current. Current is produced, how much current flows depends upon the voltage applied for given the resistance. So controlling, that means by controlling voltage, you control the armature or the field flux. So the speed can be controlled. Then if I take, if I take constant speed operation, especially shunt motor. Is possible over a range of speed. Sometimes in some books they say stepless speed change. I vary the voltage, say for example 0 to 200 volts, correct? My speed varies 0 to 3000 RPM and torque varies 0 to 20 Newton meter. Please know that it is like CVT, correct? The torque varies, speed varies, and I vary voltage. It is also, that is the advantage, correct? Low speed has a low voltage, low current, this one. As I increase the voltage, the current increases and torque increases, motor speed increases smoothly. But in IC engine, you have to change the gears, correct? So that's why they call stepless speed change is possible with the DC motors. If you are using your electric vehicle, that is advantage. Compared to no gearbox is needed, directly motor can drive, and the speed change can be achieved by changing the voltage apply, which in turn change the current and the flux. Again, quick starting. Starting electric motor is very simple. It can, if you apply voltage, immediately will start. In IC engine, you cannot do it. You need some time, no? From start immediately, at least it takes few seconds. Right? This is quick starting is possible. And similarly, stopping also so simple, relatively. Correct? So remove the power, immediate motor comes. Engine takes some amount of time, correct? Then reversing also easy, electric motor reversing. So change the polarity of DC motor, change the polarity of the voltage, the motor will start running reverse. So you want to change your reversing vehicle also easy. Okay, that is another most important thing. And you can generate high accelerations easily, quick. All these things are possible. Then high starting torque in series mode, correct? Series, the motor I told you, by having a construction such that using some mechanism switches, the motor coils will be there, but how the voltage or whether it is connected in series or parallel, that's what the suburban driver is doing. In the driver panel, there will be a lever. If you put in one mode, it will be series, just turn, the coil will be connected in shunt mode internally, using a relay mechanism internally, correct? So the high starting torque as high as 500% for short duration, correct? 500% of rated torque is possible in electric motors. You in IC engine, 500% means your engine will be so big, or at least 4 times as big. It is not possible. Here, for same size, same this one, but you cannot run the motor for longer time. It will get overheated, burn. But if you want very high torque, even for 500% possible with properly designed cooling system, all those things. High starting torque is possible. Then it is free from what you call the free from harmonic distortion. Which is the one of the drawback in AC type motor. That is induction motor, synchronous, which we are going to see, AC type motors. The harmonic distortion, because you are applying AC voltage, they will generate first harmonic, second harmonic, third harmonic. They will interfere with nearby equipment, electronic devices, control system. That is not there in case of this DC motor. Anyhow, in the world, everything is not completely good, completely bad. These are advantages, but definitely there will be some disadvantages. Anything will have at least few disadvantages. Main problem is generally for this same size and torque, and I'm talking physical size, torque and power, correct? The DC motors will be costlier, high cost, right? Same power, torque and size, physical size, all those things. DC motor, I want 1 HP DC motor, go and ask, they will say 40,000 rupees or 25,000 rupees. Because they need a lot of control, all those things. Motors are very expensive. If you want to build your own small electric vehicle, you want to buy DC motor, you'll see the very right. But for same power, if you go to AC motor, 1/3 of the price, at least 50% less AC motors. So DC motor, this is the same size, they are high cost. Then increased maintenance compared to, I am talking about increased maintenance compared to AC motors. The increased maintenance cost. because of the commutator and brush getting worn, brushes getting worn out. Because physically they're worn out because they're touching each other. Correct? I showed you this figure. Yeah, you can see here. From the battery, wires are coming, touching the brushes, these brushes. This is rotating. Commutator gets the power from the brush. Brush will be having a spring loader, so it will be pressing against this one. So there's a rubbing, constant rubbing. Because of that, the brush as well as the commutator will get worn out. Not within 1 day, 2 days, within 6 months, 1 year slowly. After 1 or 2 years, depending how long continue, you need to change the brushes because generally made of carbon material. Okay. The commutator also will be get damaged after a few years. So you need to change the entire assembly sometimes. Correct? That means physically you have to remove the armature, completely open the motor one side, remove all those things. That is this one. Another thing, since you can see that when the commutator rotates, correct? When the commutator rotates, on particular state, there's the contact between the brush and commutator will be breaking. Correct? Once it breaks, the current flow will be stopped. Automatically, spark is created. Like your spark plug in the commutator, whenever the brush disconnects from the commutator, because there's a small gap. Correct? You can see that there's a small gap. During that time, both the brushes will there will be disconnect from the current flow is stopped. Then sparks created. Spark is created. So that produces EMI, electromagnetic interference. Just like your spark plug, DC motor, commutator brush assembly also create the EMI noise. Spark, electrical sparks, due to that there is electromagnetic noise is created. Then that is one of the drawback of DC motors. Okay. Spark or electromagnetic interference, which is also called noise. Electrical, we call it as electrical noise. Correct? This will affect your ECU. Correct? Suppose in your electric vehicle, you have ECU for control, brakes, everything, vehicle control. This noise created if you use a regular DC motor, it may go and create problem. Reset the circuit, all these things. So this is a problem. In that case, you can go for AC motor. Small motor, okay, but when a high power motor, the EMI interference will be very high. Okay, that is okay. So you can expect some simple problems from the write about a series motor, shunt motor with the schematic, correct? And write the equation of for torque and speed of the shunt motor. This is more draw the characteristic curves, correct? Characteristic curves of DC motor, speed versus current, current versus torque. These curves, okay, then maybe a simple problem, calculate the speed, all this when P value, A value, Z values are given from the equation. That's what you can expect from this. So, but I want to stop with this. As per DC motors are concerned, these motors are nowadays not used, okay, in electric vehicle, but maybe old generation vehicle it may have. But before closing, I wanted to say the speed control of DC motor, how the speed can be controlled in the DC motor. We can talk about that. Shall we give you a break for 5 to 10 minutes and then we start next class?
Sir, we can take a break, sir. We can
Yeah,
take a
10
break.
minutes break. Now it is 5:55. After 10 minutes, you can join. So we will take next class. Okay.
Okay, sir. Thank you.
Thank you.